Hello boys and girls and cougar parents. Tonight we're going to work on literal equations. Now literal equations are equations where we solve the equation in terms of the other variables in the equation. Let's take a look at a few sample problems on tonight's assignment. Solving literal equations. Well, the first step of solving literal equations is just like solving any other equation. It's isolating the variable. The only thing that's a little different about literal equations is you're going to solve the variable in terms of the other variables. But let's begin. You'll see. Okay, for number one, I have P is equal to IRT. Okay, principal is equal to interest times rate times time. And I want to figure out what just T is in terms of these other variables. Well, I need to isolate T. And how do you isolate T? You begin by asking what's happening to T. Well, T is being multiplied by R and T. So what is the inverse of being multiplied by I and R, Well, it's dividing it by I and R. And what I do to one side, I do to the other. Okay, and these cancel out, and I'm left with T is equal to the P divided by IR. Okay, it's that simple, really. Now, let's look at number two. Number two, I have area is equal to 2 times the sum of the length and width. Well, the first thing I need to do is simplify. I'm going to simplify by distributing the 2 to both of these terms. So now I'll get A is equal to 2L, and then 2 times W plus 2W. Now I want to solve in terms of W. So I need to ask myself what's happening to W. Mathematically, it's being multiplied by 2, and it's also having 2L being added to it. Well, I need to do the inverse of both of those operations. And I'm going to take care of what's being added to it first. I'm going to subtract 2L from both sides. When I do that, that cancels out the 2L on here, and I'm left with 2W. Okay, and 2W is equal to A minus 2L. Okay, there's still one operation being performed on W. It's not quite yet isolated. We're getting closer. Okay, what's happening to W? It's being multiplied by 2. What's the inverse of that? Divide by 2. So I'm going to divide both sides by 2. The 2's cancel each other out. Finally, W's isolated. And what is W equal to? Well, it's A divided by 2 minus, and then 2 goes into 2L, minus L. Because I'm distributing this 2 through division. I'm dividing the A by 2, and then I'm dividing the 2L by 2, which would give me just L. Let's take a look at 2 more problems. Let's take a look at numbers 3 and 5. Now, number 3, I have y is equal to 5x minus 6, and I want to know what x is. Okay, well, let's begin by isolating the variable x. I look at the x side of the variable, and I see that it's being multiplied by 5 and subtracted by 6. I need to do the inverse of both of these operations. I first have to go in inverse order of operations, which is remove whatever's being added or subtracted. And how do I get rid of a minus 6? I add 6. And what I do to one side, I do to the other. Okay, they cancel each other out. Now I'm left with, I bring down my 5x is equal to y plus 6. Okay, now what's happening to the x? Well, x is being multiplied by 5, and what's the inverse of multiplying by 5? Divide by 5, and what I do to one side, I'll do to the other. The 5's cancel each other out, and x is equal to y plus 6 divided by 5. And I can't really simplify that anymore. Number 5, I have x plus y divided by 3 is equal to 5, and I want to solve in terms of x. Well, I see a bunch of things happening here to x. Well, not a bunch, but I see 2 things. It's being added, y is being added to it, and it's being divided by 3 at the same time. So I have to get out of this. I have to get this out of fraction mode here, and the best way to get rid of a fraction is by multiplying it by its denominator. So I'm going to multiply this by 3, and what I do to one side, I need to do to the other. Okay, that cancels out. Now I have x plus y is equal to 5 times 3, which is 15. Okay, there's one. Y is being added to x. I want to isolate x.
It's 5 o'clock.
So I'm going to subtract y from that side, and I also am going to subtract y from that side. The y's cancel each other out. I bring down my x, and x is equal to 15 minus y. Let's take a look at two more problems, number 7 and 9. Number 7, we have ax plus by is equal to c, and we want to solve for y. Okay, so we need to isolate the variable y. There's a couple things happening here. We're adding ax to y, and it's also being multiplied by b. I'm going to get rid of the ax first by subtracting it. What I do to one side, I have to do to the other. Okay, that cancels out. I bring down my by is equal to c minus ax. Now, y is being multiplied by b. The inverse of that is divide by b, and what I do to one side, I'll do to the other. The b's cancel each other out, and I'm left with y is equal to c minus ax, and the difference of that is being divided by b. That is my final answer. For number 9, I have v is equal to LWH, and I want to solve for L. Well, one thing I can notice right off the bat that's happening to L is it's being multiplied by WH. So the inverse of that is divide by WH, and what I do to one side, I need to do to the other. Okay? My W's and my H's cancel each other out, and I'm left with L is equal to V divided by the product of WH. And there's my answer. As always, I hope that was helpful, and if you have any questions, please bring them to class tomorrow. Looking forward to seeing you then. Bye-bye.